Hello, my name is Omar Elshemy, and in this video I'll be doing question number 2 in this question's test code. I can't show the question in the video due to copyright reasons, so I included the test code for this reason. So if you'd like to follow along with me, feel free to do so. So the first part of the question asks us to describe and explain the trend in atomic radius across period 3. So, as you know, these numbers up here are what are called groups, and these numbers on the side here are known as periods. So this question is asking us to focus on period 3. Now, periods normally correlate to the amount of shells that an atom has. So, for example, if we were to draw an atom here, then an element in period 3 would have 3 energy levels, as here. Sorry for the bad drawing. So the question asks us to find the correlation, to explain the trend in atomic radius across period 3. So as we go down the period, the number of shells will stay the same. This means that the shielding of electrons will stay the same, because there are still the same number of electrons in the inner shells blocking the nuclear charge of the protons. So as more electrons are added out here, they are getting pulled on by the increase in protons, because as we go down, each element has an increased atomic number, meaning that there's an extra proton that is pulling on these electrons on the outside. And this pulling shrinks the radius because these electrons are pulled inwards. So as a result of this, we can say that due to the nuclear charge, the attraction between the protons and the electrons and the valence electrons increases, and that would shrink the atomic radius. So for the second part of the question, we are asked, a student formulates the following hypothesis. If phosphorus were to form a positive ion, P, with a positive 3 charge, its ionic radius would probably be between 110 times 10 to the power of negative 12 and 212 times 10 to the power of negative 12 meters. So explain this hypothesis, or evaluate this hypothesis. So for this question, we will need the data booklet for chemistry. So a student estimates that the ionic radius for phosphorus would be around 110 times 10 to the power of negative 12 and 212 times 10 to the power of negative 12 meters. So if we are to look at our chemistry data booklet right now, it says that the ionic radius for phosphorus is 109 times 10 to the negative 12 meters. So this means that this student's estimate is wrong, because 109 is definitely smaller than 110 and is not between the range of these two numbers. So now we have to evaluate or say why he's wrong. So if we look here, again, phosphorus, period 3, and it is really far over to the right, which means, again, that the nuclear charge is really strong because those protons are really pulling on those electrons. Sorry for this really bad drawing, but so the electrons are trying to orbit here, but the protons are just not letting them. They keep pulling them in and in because that positive 3 charge, there's more protons pulling them in. So that results in a smaller ionic radius than the student's estimate, which is why he is wrong. And that's it for this question. It's a short one today, but hopefully it shed some light on topic 3 a little bit, and I hope you enjoy.